Hi guys, so in this video tutorial, we will see how we can use YOLOv8 for football player and ball detection. So this is an end-to-end tutorial. We will start with, first we will create our own data set. So I will go to RoboFlow and create an account over there. Then I will gather a data set from different YouTube videos. Then I will train my YOLOv8 model and then test our model on different videos. Plus, we will do real-time testing on the webcam as well and see what results do we get in real time. So let's get started. So let me go, go to RoboFlow. Okay, so just click on the first link. And if you haven't created an account, you just need to sign up. So I have already have an account, so I can sign up. But to tell you how you can create your account, I will go to sign up option and just create an account over here. So it might take few seconds. So sign in Google. So I'm just creating an account. I don't have an account on this email ID over here previously. Okay, so just clicking on so it might take a few seconds for it to complete the process. Okay, login or create an account. So I accept the terms of service and privacy policy. Continue. So here I will click on Academia, workspace name as Moin. I will skip, and I'm a recommended community, so public. So all my datasets will be public if I use this. Or if you want to make your dataset private, then you have to get a subscription package. Okay, so I don't need a guided tour. So I will click on create new project. Okay. So I will doing object detection of player and football. So I am detecting football player. So these are the two things which I am detecting: football and player detection. Okay, and tracking. So this will create a public project over here. So so if you don't have any data set for our project, so let me show you how you can create your own data set. So I will have just go to the YouTube and just I will from here, let me copy link address and just see. So I will just paste it over here and just click on enter. So it will now process the video, complete video frame by frame. Let me show you. So 60 frames. Okay, so the video is around 2 minutes 7 seconds. So it's around 128 seconds. The video duration is 127 seconds. And from each seconds, we will get a one frame. So, okay. So we have chosen the frame rate. So it might take some time to process all this video. So in the meanwhile it process this video, let me go to let me look some for another video. Let me look so for Portugal match video. Okay, so let us just copy this link. In the next phase we will we will annotate this video as well. So in the first phase we will just upload this video, and then I will upload the second video as well. Then I will annotate both the videos one by one. Okay, so it might take few seconds more. So let's wait and see. So in the output we will be getting 128 images, as you can see over here. So let me get back as it's uploading completes, then we will discuss further. Hi guys, so we were able to extract 120 frames from the video, and you can see that they are not annotated yet. We will annotate our data set. They are all not annotated from, you can see from here. So let me upload another video from here, but let me first save and continue this. I'll just click on save and continue. So now these images will be uploaded into my data set. So it might take some time. After these images get uploaded, we will take another video and upload, extract frames from that video, and then we will upload those images as well. So it will be 3 seconds only. So very soon it will be uploaded over here. So let's see, 3 seconds remaining appearing. So let's see how it goes. Okay, so it's uploaded and okay, so the files are uploaded and we can see that. So basically, I'm the only one working on this project. So I will assign the job of these images annotation to myself. So I will just click on assign images. So after this, now I will annotate every single image one by one from here. But before we start annotating, let us upload some other videos as well. Then we will do the annotation of all images once. So just copy link address and just paste this link address over here and click on enter. So it might take some time. So let's see. They're downloading. Please wait while we process our video. So just choosing the frame rate a bit higher. So just trying to explain you. So you can set the frame rate as 1 frame per second, which we originally did in the first video. So let's click on save and continue. I will also take other videos as well from YouTube and annotate them once as well. So just click on assign images. So I will assign the job of these images annotation to myself. So now we can see that we have two jobs for the annotation. This is for the first video and this is for the second video. Let me go to the stuff first video first and let's open this image first. So let's click over here and let's do the annotation. So in this way, we will annotate all of the images which are in our data set. You can see here. So you can see that I am annotating every single image over here. In this way, I will annotate all the images in the dataset we have, and then annotate this as well, and then annotate this image as well, and then we will annotate this image as well. So in this way, we have annotated all the images. These two are left. Let's annotate them as well. Okay. So I have assigned the label football player to these images, to all the labels over here. Now let's annotate this football first and assign the label as football. Okay, so no, I think I missed it. I just don't click on the save button. Okay, so just click on save, enter. What's the issue which I'm getting? So basically, I'm making a mistake. I'm not creating a class football, so I will click on football. So now it has created a class football. Now I will annotate these other players by click on football player and this one as well, and this one as well, and this one as well. And in this way, we'll annotate all the images in our data set one by one. Like you can see that I am doing over here. I will not annotate the referee. I will annotate all the other ones. So and in this way, we are annotating basically all the images and this there as well. Now we'll go to another image and do the annotation as well. So first of all, we will annotate the football over here. And now we'll do the annotation of all the players. Okay. So in this way, we will annotate all the images in our data set. So let me annotate all these images and get back to you. So guys, I have annotated all the images in the data set for the football and for the football player. And you can see that we have total around 1,827 images, two classes. The one is football and other is football player. So we have around 1200 images in that training set, 675 images in the validation set, and currently we are not taking any images uh, for the testing set, but I will rebalance it and make it around, I will make it around 100, and let's make around. Okay, so in this way, I will rebalance my data set. So currently we have 58% images in the training set. After implementation, this percentage will increase and 27% images in the validation set and 15% images in the testing set. So let's click on continue. So I am resizing my all my images to 6 cross 40 cross 640. The reason for resizing all the images to 640 cross 640 is that basically our YOLOv8 model is trained on 640 cross 640 images, and if we are just filtering none, if there is an image on which no annotation is done, so it will be skipped. So basically, as you can see, filter none require all the images to contain annotations. Now, so if our data set size is not enough, so we need to augment the data set so that we can increase our data set, plus we can make our model a bit more aggressive against the bit more aggressive. So our model gives more better results if we do augmentation. So here I am generating augmented data. For example, this is an image. It will create two more images from this image, which is one will be minus 15 degree rotated and other will be plus 15 degree rotated. Plus we are doing this, we are just changing the contrast of the image. So it will generate two images from this original image with different contrast like minus 25 to plus 25. It will randomly adjust the colors. And then we are also adjusting the brightness. So from this single image, we will generate two images. One will be more bright and one will be dark. Okay, so and just will click on continue. Now I will click on generate. So as you can see that we are generating two images from a single image, so that our data set will definitely increase now. Okay, so we can train our model in your RoboFlow as well, but we will click on export because RoboFlow provides a no code solution, but I always like to do some code work. So I will click on export and export this model into our YOLOv8 collab file, and then we will train our model and do the prediction on some output videos as well. So just copy this command to down export the dataset from RoboFlow into your Google Colab notebook. So I'm just copying this and just go over here. So first we will connect our Google Drive with the Google Colab so that when we run training, our weights are saved into the drive. So if there is a sometime disconnect or runtime restarts, so our weights will be saved into the Google Drive. So just mounting our Google Colab notebook with the Google Drive. So I have already trained your model, the models, but I will overview all the steps that I follow to train this model. So from IPython to display import image, because if you want to display some input output image into our Google Colab notebook, so we need this library. And then so then I will create a folder in my Google Drive by the name football. You can see this folder over here. This is a folder named footballs, and just setting this folder as my current directory. So for this project, I will be using, let me show you. Okay, so I will be using this GitHub repo for this project. You can see over here. So you can just click over here and just copy this link from here and just clone this GitHub repo over here by just Control V. So basically in this folder, I have already mounted my Google I have already cloned this GitHub repo, so it's downloading over here. You can see that. So I've already downloaded this GitHub repo. So, or you can say I've cloned the GitHub repo So you just need to run this cell, and then you will see the what is your present working directory. Okay. So now I will select my current directory as this GitHub repo which I have cloned over here. So just click on copy path and just paste this over here and just run this cell. Now we need to install all the requirements or dependencies to so that all the libraries get installed like matplotlib, numpy, cbound. So when we run out the training or the prediction, we should not face this error that the following libraries is not installed. So when you run this, so it install all the dependencies, all the libraries. So we don't face an issue. We run this dependencies installer script. So it might take few seconds to run. So let's wait and see. So the dependencies are being installed now. Okay. Like you can see that we are just installing a Jinja 2, Markdown, Ultralytics, and so on. So now we are just moving towards the required directory, detect, because we are performing detection. So we'll go to YOLO, Ultralytics, YOLOv8 and click on detect. And we will just move towards this required directory because we are performing detection. Now basically we have created this data set into the our RoboFlow. So we will just copy this from here and just paste this all from over here, and just if you run this cell, it will be downloaded over here. Like it has been downloaded over here, you can see. In this way, you can simply run this cell and download this dataset from RoboFlow into the Google Colab notebook. Then we basically, to implement deep sort tracking, we need to download the deep sort files because we are implementing object tracking using deep sort. So I have placed the deep sort file into my Google Drive. So I'm directly downloading those files from the Google Drive into the Google Colab notebook. So just run this cell. So it will download the deep sort files from the Google Drive into your Google Colab notebook. And by running this cell, you can unzip those files. So already, as you can see that I have already downloaded these files. So from deep unzip, I have already unzipped these files, but I will click on all and unzip these files again, because I have already run this script before making this video. So already these files are downloaded and unzipped. So now I will run training. I will train the custom model of YOLOv8 model on this football player and football dataset. So I am be choosing YOLO V8L model. So we have 5 different models available in YOLO. So if we choose the smallest model, which is YOLO V8N, so it will give us it will be fast and it will take less training time, but it will be less accurate. While if we choose YOLO V8, which is the best accurate model, so YOLO V8X is the best accurate model, but it takes more training time and but it gives the more best results. But the training time taken by YOLO V8X is more than other models, and its processing time is quite higher than the other models as well. So I've already trained this model on, you can see that around 78 epochs. So I will not be training this model again. Okay. So I will just go through the files in the runs detect train folder. So when after we complete the training, so we can review the files we have in the training folder. So we can see that we have the F1 curve, precision curve, recall curves, and we have also the training and validation results as well. So if we want to display the precision curve, we can also display we have the class football and player, and plus we can also display the precision recall curve. And I have saved the model weights into the Google Drive. So if we just, in case we want to directly download the weights from the Google Drive, we can also download the weights from the Google Drive as well. Okay. So in the next step, if I will validate my custom model. So we can see that we are getting a good mean average precision with IOU 50 as 0.887 and 0.913, and with when mean average precision when IOU varies from 15 to 95 is 0.631 for football and 0.476 for the player. So these results are very good. Okay, so we will just download some demo videos to test how our model works. Okay, so I have downloaded some demo videos from the Google Drive. You can see that over here. So let's run over this demo video and see what results do we get. So it might take some time for the script to execute. So we will wait and see our script execute and what results do we get in the end. So now we are just performing predictions. So let's wait and see what results do we get. After doing the prediction on some sample video, I will test this model on live webcam as well, and we will verify our results from there as well. So it's 22 player, 21, 1, 1. Okay, so it's detecting the players as well as the football you can see over here. So I think the model working fine. Like the players are being detected, the football is also being detected. You can see from here. So it might take some time. So as it completes, I will be back and then we will see what the results we get. So the prediction on the demo video has been done. So just let's copy this from here and see what results do we get. Okay, so just copy this path and just paste this path over here and just write videos to dash trim. This is the output video name. Okay, so let's see what results do we get. Let me show you basically where my results are saved. Go to my drive, football, YOLOv8 deep sort tracking. Then I will go to YOLO runs, detect, train 14. And this is the output video name. So just we need to copy path from here and just paste this path over here. I have just done this manually, but you can also do this by Control V and just see what actual results do we get from the output. So it might take some time, so I can just directly download these results from my drive. Let me go towards there and just click on new tab and just go ahead drive. And then I will go to football. And here I will go to YOLOv8 and then I will go to runs, detect, train 14. Okay, video 2 dash trim and just download this output video. The file size is large, so it might not be able to display our Google Colab notebook. So, okay, so we can see the results here as well. You can see those. Okay, so here the ball was detecting football. So let us see so along from the other. Here the model is also able to detect the football as well. But here the model is making that wrong prediction with the player and football. Okay, here the model is also able to detect football. So overall, the model is working fine, but in terms of player, but in case of football, some detections of football gets missing. But you can see that we are able to detect the player and assign a unique ID to each player and track the player as well. And we have the trails as well. You can see over here the trails as well. So I see a mistake over here. Like basically, you can see that we have different players in this video. So each player is being assigned a unique ID, like 253, 34. But we have a single football. So we can have trails, but we don't need a unique ID with the football. So I think we should remove it. So what we need to make the change in the code, let me show you. So just open the predict.py file and just go over here and just write if label is equal to football, okay, and just create another thing L if label is equal to player, okay, and just press enter and just copy, just make one change, just set this as now and just copy this from here and just paste this from here and just remove this. Okay, so label percentage. So I think it will now work fine. We will not have a unique ID with the football and just save this. Okay, and just run the script again and see what results do we get now. Okay, let's not this. Now just run this cell and see what results do we get. I hope we will not be able not getting the ID with the football because we don't need it because there is a single football in the match. Although they are different players, so they can have a unique ID, but we don't need uh, ID with the football. Let's see what the error we are getting. Local variable label referred before assignment. Let's see what's the error. Let me open the predict.py file. And I think I have made the mistake and it will be, okay, I'm recognizing right. So here it will be object name and here it will be object name as well. So now it will work fine and I hope we will not get any issue. Let's run, but if there is an issue, we will definitely fix it. Okay, so just checking, renaming this file as well. So it might take some time and let's run this script as well again. Okay, so we are now running this script again. So I know it might take more time fusing layer. Okay, the it has started. So as this process complete, the predictions are done on each frame. Then I will back and we will see what output video we get. Hi guys, so the predictions on the videos are done. So I have just downloaded this output video. So as it completes, I will show you the results, whether the ID assigning is being removed from the football or is still there because because there is a single football in the match. So we don't need IDs in different IDs in each frame rate. We only need unique IDs with the football player. So just open this and just see where, okay, so I think it's working now. And just, okay, so you can see over here, we don't have a unique ID with the football, we only have the trails. That's fine. Although we have the IDs with the players and there is no ID, unique ID with the football. So that's superb. The unique ID with the football has been removed. We only have the unique IDs with each of the players. Okay, 271, 270, 273, that's perfectly fine. Now what we will do is we will test this model on live webcam as well. I have a football, I will just pick it up and I think it will detect myself as a player. So let's test this model on the live webcam. So to test the model on the live webcam, I will download the weights file from here and let's see what results do we get over there as well. So now you can see that we are testing our model on the live webcam. So as I'm not a player, so it's not detecting because I'm not just as a player. So it's not detecting me as a player, but you can see that the football is being detected by the webcam. So our model works very fine over here. The model is able to detect the football. You can see over here. And as I'm not being dressed as a player, so the model is unable to detect me as a player, but the model is very successfully detecting that there is a football and the results are quite fine. Uh, Very good. Because I'm not standing or I'm sitting and I'm not dressed as a player, so the model is unable to detect me as a player. While with the in case of football, the results were very perfect and they are very fine, super results. So that's all from this video tutorial, and see you all in this next video tutorial. But just to show you that I have written this script for to do predictions on the live webcam. You can see over here I have written from Ultralytics import YOLO model is equal to YOLO. Here I pass the weights file which I have downloaded from the Colab file. So these are the weights file of my model, and here I'm just doing prediction. So I'm setting source is equal to 0, show is equal to true, so that I can see the testing live, and confidence value is set as 0.15. So this is all from this video tutorial. See you all in the next video tutorial. Till then, bye bye.